In this video, we're going to look at another method for factoring polynomials, and this is primarily going to be used when we have polynomials that have more than 3 terms. However, this is also going to be kind of familiar because we've done something similar to this before. This is factoring by grouping. So the first thing I'm going to do when I look at my polynomial is look for terms that have a GCF other than 1. And I'm going to pair those terms that do have a common factor and pull out that GCF. So if I look at my first polynomial here, I'm going to split it into 2 groups. And a lot of times it doesn't matter how you group the terms, you're going to end up with the same result either way. And if I look at the first group, I see that my GCF is going to be 7x squared. So we factor that out, and when we do, we're left with x plus 5. I bring down my plus sign, we look for our GCF in the second group, which is a 5. When we pull that out, we're left with x plus 5 as well. Now between my 2 terms, I have a common factor of x plus 5. So I'm going to factor out that x plus 5, and we're left with 7x squared plus 5. So this would be our final factored form. This is exactly what we did in the last lesson when we broke down polynomials that had a lead coefficient other than 1. We found those 2 numbers that enabled us to split up the middle term. We broke our polynomial into 2 groups and basically repeated this process here until we were in factored form. So go ahead and pause the video and try the problem on the right. Alright, so if we leave the terms as is, the GCF of the first 2 is r squared, and then the second, it's 6. Inside for both of those, we get 7r minus 6, and we have our factored form below. Remember that since multiplication is commutative, it doesn't matter the order in which we write the 2 factors. So I could also write this one as r squared minus 6 times 7r minus 6. Those would both be the same thing. Alright, now again, sometimes we might have a greatest common factor that we can handle either before we start factoring or at the very end. We're going to take a look at what happens when we leave that GCF in, and then we'll take a look at how we can handle it right at the beginning. So I'm going to ignore the fact that all 4 of these are divisible by 4, and I'm going to go ahead and start to make my groups. So if we look at the first 2 terms, we have a GCF of 4x cubed, and when we pull that out, we have a factor remaining of x minus 2. I bring down my plus sign, now I look for my GCF of the second group, which is going to be a 12x, and left over again we have x minus 2. So we pull out that x minus 2, and we're left with 4x cubed plus 12x. But now if I look at that second binomial, I see that I have a GCF. For my coefficients, I have a GCF of 4, and then I also have a GCF in my variable. So we can break that one down into 4x times x squared minus 3. And for my final factored form, remember that we're never going to leave a monomial factor sandwiched in the middle. So we're going to pull that out front, and then we have our x minus 2 and our x squared minus 3. You could also write this as 4x times x squared minus 3 times x minus 2. Remember, it doesn't matter the order in which we write those binomial factors. So that's if we save it until the end. We have to be on the lookout for it, and we have to catch it here. But we can also pull it out in the beginning. So if I look at this polynomial, I say, hey, these are all divisible by 3x. So we factor out that 3x. And left over, we have 2x cubed plus 3x squared plus 4x plus 6. And now I'm just going to use my grouping on the terms inside the parentheses. So I have my first 2 and my last 2. And this all occurs inside the parentheses that are being multiplied by 3x. So my first GCF here is just x squared, and left over we have 2x plus 3. My second GCF is going to be a 2, and left over we have 2x plus 3. And then we pull out that 2x plus 3, and we have left over x squared plus 2. So we have that monomial term in front, and then our 2 binomial factors as well.